Hi everyone, in this video we'll discuss insertion sort. So insertion sort is a sorting algorithm that builds the final sorted list one item at a time. So basically the input list or array is virtually split into two parts. One is the sorted part and the other is the unsorted part. So in each iteration, we pick a value from the unsorted part and place it at the correct position in the sorted part. So when a human manually sorts something, the method that we use is similar to a insertion sort. So let's say a person has to sort a deck of playing cards. So the usual method that we humans take is that we pick a value and place it at the correct position. Then we pick another value and place it at the correct position. So going by this manner, at the end all the cards are arranged. So that method is similar to the insertion sort. So let's see an example. So this is the input array that we are given. So we'll split the array into two parts. Let's say we are sorting it in increasing order. So this is the virtual split of the array. So the first element will remain as it is. So let's say this is the sorted part and the unsorted has 15, 6, 11, 12, 2, 1, 4 and 6. In the next step, we pick an element from the unsorted array and place it in the correct position in the sorted one. So 15 comes after 3. So the sorted part becomes 3 and then 15 comes. And in the unsorted part, we are left with the remaining elements. In the next iteration, we pick the next element from the unsorted array, which is 6, and we'll now place 6 in the correct position in the sorted part. So the correct position of 6 is between 3 and 15. And now the unsorted part which remains is 11, 12, 2, 1, 4, 6. So you can see that in each step we are adding one element to the sorted part. So we are building the sorted list one item at a time. In the next iteration, we pick an element from the unsorted part and place it in the correct position in the sorted part. So 11 will come between 6 and 15. In the next step, we'll pick 12 and place it in the correct position. So 12 will come between 11 and 15. In the next iteration, we'll pick 2. So 2 will come before 3. Now we'll pick 1. So 1 will come before 2. In the next iteration, we'll pick 4. So 4 will come between 3 and 6. And in the unsorted part, we are left with the last element, which is 6. So 6 will come between 6 and 11. So the final array that we'll get is sorted. So all the elements are now in the sorted part and the unsorted part is empty. So in each iteration, we'll pick an element from the unsorted part and place it in the correct position in the sorted part. So that is how the insertion sort algorithm works. So the name is derived from the fact that in each step we are inserting the element in its correct position. So since we are inserting the value at the proper position, so that is why this algorithm name is insertion sort. Now once we've understood that how this algorithm works, let's have a look at the pseudocode. Let's take this example. So in this case, the array size is 8. So we'll iterate from the first element till the last element. So I is currently at 15. We'll keep an element key and we'll store the value of index I in key. So array of I is 15. And we'll have a variable j which will point to the previous index of I. So j will point to 3. Then we'll run a while loop and compare all the elements before I with the key. So we are storing the value of array of I in key and we'll compare all the elements before I with the value present in key. So for the first case, array of j is 3 and key is 15. So this statement is false. So the while loop terminates, and then we set array of j plus 1 equal to key. So array of j plus 1 means the index of 15. So at this position we are setting value 15, which means it won't change because 15 is already present at this location. So in the next iteration, now I is pointing to 6 and key becomes array of I. So key is also pointing to 6 and j is I minus 1. So j is pointing to 15. So the idea is that before I, all elements are sorted. So 3, 15, these are sorted. So when we want to include I in the sorted part, we need to find the correct position of I in the sorted part. So we'll start comparing all the elements before I. So for that we have this variable j. So whenever we find an element which is greater than I, we'll move that element to the next position. So in this case, we run this while loop and now array of j is 15 and key is 6. So this condition is true, which means we'll set array of j plus 1 equal to array of j. So array of j is 15 and j plus 1 is 6, which means we'll change this 6 to 15. So the array now becomes 3, 15, 15, and then we decrement the value of j. So j will come at 3. In the next iteration, we check if j is greater than 0 and we compare array of j, which is 3, with the key, which is 6. So this statement is false. And now we set array of j plus 1 equal to key. So value of key is 6. So at array j plus 1, we set the value 6. So j is pointing to 3. So j plus 1 means this value 15 will be changed to 6. So we first save the value of I in key, and after we are done adjusting all the previous values, we'll set the value of key. So after this step, the array becomes 3, 6, 15 and the remaining is the unsorted part. So in the next iteration, now I points to 11 and key is value of I, which is 11, and j is pointing to 15. Now in this while loop, we'll compare array of j with key. So array of j means 15 and we have to compare 15 with key, which is 11. So this is true, which means we need to set array of j plus 1 equal to array of j. So at this value 11, we'll set 15 and then we'll decrement j. So j will come at 6. And in the next iteration of while loop, we'll compare array of j, which is 6, with key, which is 11. So this statement is false. So while loop will terminate and then we'll set array of j plus 1 equal to key. So array of j plus 1 means this value 15 will be replaced by 11, which was the key. So after this step, the array becomes 3, 6, 11, 15 and the remaining is the unsorted part. And in the next iteration, I comes at 12. So you can see that all the values before I are the sorted and all the values after I, so these are the unsorted part or yet to be processed part. So in each iteration, we are placing one element from the unsorted part into the sorted part. So now in this step, key becomes array of I, which is 12, j points to 15, and in this while loop we'll compare array of j, which is 15, with the key, which is 12. So this is true. We'll set array of j plus 1 to array of j. So this 12 will be changed to 15 and j will be decremented by 1. So j will come at 11. In the next iteration, will compare array of j which is 11 with the key which is 12. So now this statement is false, so the while loop will terminate, and now we'll set array of j plus 1 equal to key. So this 15 will be replaced by key which is 12. So after this step, the array becomes 3, 6, 11, 12, 15, 2, 1, 4, 6. And in the next iteration, I comes at 2. And the value of key is array of I, which is 2. And j is I minus 1, so j is pointing to 15. Now we come in this while loop and we compare array of j with key. So array of j is 15 and the key is 2. So this statement is true. So we set array of j plus 1 to array of j, which means we replace this 2 with 15 and we decrement the value of j. So j comes at 12. And in the next iteration of this while loop, we'll compare array of j which is 12 to the key which is 2. So this statement is also true. So we'll replace this 15 with 12 and we'll decrement j to point to 11. In the next iteration, we'll compare array of j which is 11 with the key which is 2. So this is also true. So we'll change this 12 to 11 and we'll decrement j to point to 6. Now in the next iteration, we'll compare array of j which is 6 with the key which is 2. So this is also true. So we'll change this 11 to 6 and decrement j to point to 3. In the next iteration, we'll compare array of j which is 3 with the key which is 2. So this is also true. So we'll set this 6 to 3 and we'll decrement j. So now j is less than 0. So this while condition will break and now will come at array of j plus 1 equal to key. So j is minus 1, so which means we are setting array of 0 to key which is 2. So at the 0th position of the array we are setting 2. So after this step the array becomes 2, 3, 6, 11, 12, 15, 1, 4 and 6. So this all part is sorted and I now comes at 1. So this is the unsorted part. Unsorted or yet to be processed. And this is the sorted part. So in the next step, we'll again place 1 in the correct position. So 1 will come at the 0th index of the array. And then in the next iteration, we'll pick 4 and 6. So in each step, we are picking one value from the unsorted part and placing it in its correct position in the sorted part. So that is how this insertion sort algorithm works. If we take a look at the time complexity, since we are running two loops and we're processing all the elements, so the average and the worst case time complexity is order of n square. But in the best case, when the elements are already sorted, let's say the array is this. So in this case, whenever we pick an element from the unsorted part, this while loop need not be processed because this statement will be false, because the element is already in its correct position. So in that scenario, we won't do anything in this while loop. So in the best case scenario, when the array is already sorted, time complexity will be order of n. So once you have seen how the insertion sort algorithm works, let's take a look at few of the properties of this sorting algorithm. So the implementation of this sorting algorithm is quite easy. The time complexity we have discussed. So best case is when the array is already sorted, so that is order of n, and the average and worst case is order of n square. So this is an in-place sorting algorithm. That means it does not use any additional space. So the space complexity is order of 1. So this is stable also. That means it does not change the relative order of elements with equal keys. So we can see in this example that there are two elements with equal keys, which is 6. So when the first part is sorted, so we will be left with 1, 2, 3, 4, 6, 11, 12 and 15, and then we'll have to place 6 in its correct position. So when we're trying to place 6, so we'll find the correct position of 6 is after this first 6, which means this 6 which was occurring before is also occurring before in the sorted array. So when the keys are same, this algorithm preserves their relative order. So that means this algorithm is stable. And the last property is online, which means that this algorithm can sort a list as it receives it. So if we take the example that we are receiving a stream of elements, a stream of integers, let's say, and we have to sort it. So we are continuously receiving some integers and we have to keep the list sorted. So if an algorithm can do that, that means it is an online algorithm. So in insertion sort, even if we pass few more elements to this array, let's say we pass 7, then 3, then 2, then this algorithm can handle all those cases because it will pick all those elements one by one and place them in their respective position. So it can handle a stream of data types that is coming to it and it can sort it. So that is why this algorithm is called as online algorithm. So it can sort a list as it receives it. So these are few of the properties of insertion sort. Now let's have a look at the implementation of this algorithm. All the source code that I'll be showing is available in my GitHub repository, link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function I have this vector, which is the same example that I've taken. I first print this vector, then I call this function insertion sort, and at the end I again print this vector to show that the vector has been sorted. So in this function insertion sort, I run two loops. In the first for loop, I preserve the value of index I in key, and in the nested while loop, I check all the previous values and place vector of I in the correct position. Once I have placed it in the correct position, then I set the value of key to j plus 1. So at the end of this function, the vector will be sorted. Let's run this code. So the input integer array was unsorted, and when we sorted it using insertion sort, the output that we are getting is sorted. So that was all for this video. In the next videos, we'll see the other sorting algorithms. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.